Hi, welcome to online tutorial series on Arduino and IoT. This is lesson 13, and in this lesson we'll talk about servo motor interfacing with this Arduino UNO. We also provide online training, online coaching, and help in technical assignments. We also do freelance project based on embedded system, MATLAB, machine learning, data science, Python, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at jcbrolabs@gmail.com. Okay, so when we talk about servo motor, so servo motor is used whenever we require a precise angular movement. So earlier we have talked about a DC motor. So DC motor is a kind of thing like if we apply a voltage, it keeps on rotating. Okay, so there is no control over the angular movement. Like suppose we want to rotate motor by 10 degree, only 10 degree, then we can't do that with the help of this DC motor. So we can do all these things using servo motor because it uses a feedback loop mechanism to stop the motor at a precise angle. Okay, so as we are seeing in this figure, this is our servo motor, which is generally available for toys application or for lower end application. Okay, so generally it has three wires. So three wires for VCC, ground, and the PWM wave. So generally there is a brown wire or a black wire. So this is ground, and then another one is the red wire commonly used, that is for plus 5 volt, and then last wire is light yellow or white wire that is used for applying PWM wave. Okay, so this angular motion, like how much angle we want to rotate this servo motor, that depends on the PWM wave or the duty cycle of PWM, right? That means pulse width modulation. So generally in order to rotate this servo motor, we need to apply pulses at a frequency of 50 hertz. Okay, so if we talk about if it is a 50 hertz, so from here we can find the time duration of the pulse as well. Now within that, if pulse width, right, so time duration 20 millisecond, so the pulse width is minimum 1 millisecond pulse width is required to rotate to put it at 0 degree. Okay, so if it is less than 1 millisecond, it will remain at 0 degree. So these are conditions for a general motor. Obviously these sometimes these specification varies from manufacturer to manufacturer. For instance, some manufacturer takes 0.5 millisecond pulse duration to keep it at 0 degree. Now if we apply or if we change this pulse width of the this PWM wave, we can change the angular motion of this motor. So let's say if we are applying 1.5 millisecond pulse with a 50 hertz frequency, the motor will rotate by 90 degree and it will stay there. Okay, it is not like that it keeps on rotating, it will stay there. Similarly, if we apply a maximum, let's say 2 millisecond pulse, then it will rotate 180 degree. Okay, so in some cases it is maximum is 2.5 millisecond. So we can say like from 1 millisecond pulse duration to 2.5 millisecond pulse or 2 millisecond pulse duration, motor will rotate from 0 degree to 180 degree. Okay, so that means there is a total 1 millisecond duration in which it can rotate by 180 degree. So we can easily find, like if we are applying 1.1 millisecond pulse, how much rotation will it take? It will take nearly 18 degree, right? It will rotate by 18 degree. Because in 1 millisecond duration it is taking 180 steps. Okay, so 1.1 millisecond it will take 18 degree. Okay, so similarly if you have any requirement like 37.5 degree or 40 degree or 50 degree, you can compute the pulse duration accordingly. Okay, now comes to the interfacing part with this Arduino. So in this Arduino case, interfacing with Arduino. So Arduino provide a library for interfacing this servo motor. So we have a library which is hash include. So this library has to be included servo.h. Okay. Now within this library, first step we have to create a object or a servo motor object. We have to create, only then we can access all other property of this one. So object is created by taking servo, let's say servo, and then let's say we have created an object by JCBR. So this JCBR is servo kind of object, and then this provide several functions, several built-in functions to interface this motor. One more thing is there, this library is only support pin number 9 and 10 of Arduino 9 and 10. Okay, so the servo motor should either be connected to pin number 9 or pin number 10 if you are using these built-in functions. You can also you can also write your own programs very easily, because it is nothing but just you have to change this pulse duration. That can be done with the help of changing the delay time. Okay, so function are accessed like, for say, first function is jcbro dot attach. Okay, so it takes 3 argument like pin number, and then other argument are optional. If we want to provide them, we can also do that. We can say minimum value and we can say maximum value. So if we only provide this pin number to which this motor is connected, this min and max argument will be taken by default value. So this function is used to connect the DC motor to Arduino. And then another function is, let's say, JCBRO. Remember, this JCBRO is the object name of servo type. Then we have jcbro.write function. So through this we can write angle. Okay, so you can write any angle to it and the motor will rotate correspondingly. So it is very straightforward. Now this angle can move from 0 degree to 180 degree. Okay, another is we can also type microseconds if we want to make it. So we can write jcbro dot write microsecond, jcbro dot write microseconds, and here we provide this information in microseconds. Okay, so it has to be 1000, between in the range of 1000 to 2000. So microsecond means 1 millisecond to 2 millisecond. So within this range 1000, 1 millisecond to 2 millisecond, this motor or the servo motor will rotate from 0 degree to 180 degree. Once again, this value is again for general motors. Suppose you are using any specific servo motor and they have their own requirement, then you can change this microseconds from like 750 to 2500 depending on the kind of servo motor. We can also write the angle of this servo motor, or what is the current angle of the servo motor. So there is a function like jcbro.read. So it returns the current angle of the servo motor. Okay, so now let's have a look on how we have connected the hardware. Okay, prior to that, let's make a connection. So in connection, we have, these are very easy connections. We have Arduino UNO board, and pin number 9 of this Arduino UNO is connected to the servo motor, and other wires of this servo motor are connected to VCC and ground as well. Okay, so now let's have a look on the setup which we have created for you. Hi, this is our setup for servo motor interfacing with this Arduino UNO. This is our Arduino UNO and this is the servo motor. Okay. Currently it is rotating and it has three wires, this black, red and brown, red and little light yellow. So this brown is ground, brown wire is ground, this red wire is plus VCC and this little light yellow wire is connected to the PWM and this is connected to pin number 9 of this Arduino. Okay, so you have seen the hardware setup. Now let's move forward with the programming part. Okay, let's open this Arduino and let's create a new folder and let's first save it. Save as it is lesson 13 and servo. Okay. Lesson 13 underscore servo. Okay, so let's first add the header file. Okay, now let's create the servo object. Okay, so now what we'll do, we will attach the servo. First object in setup plan jcbro dot attach. So this servo is connected to pin number 9. We will connect it to pin number 9 and then we can at the initialization we can also make the initialization. Let's move this servo motor by a say of 30 degrees. So jcbro dot right, let's say 30 degree. Okay, so what will happen as soon as it will start servo motor, let's okay, second more easy, servo jcbro dot right. First we will make it to 0 degree so that it remains at the initial position and then we will provide some amount of delay, let's say 2 seconds. Then after 2 seconds it will rotate to 30 degree and it will remain there. Okay, so let's have a look and let's upload this to Arduino. Okay, Arduino is selected, Arduino UNO is selected. Okay, let's upload it. Now it is uploading. Restart or reset the system. First it will go to 0 and then it will set to 30 degree. Yes. Okay, so the program is exactly working fine. Okay, so you have seen how it is working. Now what we'll do, we will rotate this servo motor at an angle of 10 degree at an interval of 1 second only. Okay, so let's try the code and we'll also be reading the status of this angle of this servo motor on the serial port as well. So we need to start serial port serial dot begin at a rate of 9600 and then we will create a for loop. Okay, because we are reading the data, so we need to create a variable as well. So let's say int angle. Okay, now let's create a loop here. So this loop will start from 0 and keep on incrementing the angle by 10 degree and then we will keep on writing the value on servo. So jcbro dot write, the value is I. Okay, and then we will also read into angle. And then we'll provide a delay of 1 second, or let's say 500 millisecond. Okay, so that's it. Let's compile and download it. Okay, that's done. Let's see the serial monitor as well. Okay, oh, we forgot to write on the serial monitor serial dot println angle. Okay, let's download it. Now let's have a serial monitor. Okay, so it is rotating at an angle of 10 degrees, an interval of 10 degrees, and similar is visualizing on it. Okay, so let's have a look at the hardware as well. Hi, so this is the code in which it is rotating. This servo motor is rotating at an angle of 10 degrees, and you can visualize the same on this chart. So it is very closely following the exact angles of 10 degrees. So this is how we can use this servo motor for precise angular movement in several applications, including robotics. Okay, so you have seen how to interface this servo motor to Arduino UNO, and it's very easy. I hope you enjoyed this video and you learned a lot from this video as well. Further, we also provide online training, online coaching, help in technical assignment. We also do freelance projects based on embedded system, MATLAB, machine learning, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can mail us at jcbrolabs@gmail.com. So that's it for this video. Thank you.